Okay, some announcements. I will post forms to reserve your final project presentation times. Okay? And yeah, I don't have any other special announcements actually. Are there any questions about the class so far? Okay. So what I want to do today is to go into one of the things that I won't give homeworks on, actually. I may ask questions in the final exam, some generic questions. But one of the things that I think is hardest, one of the hardest things to do right, or that, you know, when I was learning Android myself, it took me the longest to understand what the need for how it is done and the way it is done. That is services. In general, in Android, you have two types of objects that are somewhat similar. The activities and the services. The activities are the things that run in the foreground and that you can look at. You know, they have a UI defined and they interact with the user. And the services are similar objects, meaning that, you know, just like an activity, they are an encapsulator of computation that can take place, so to say, right? But they are used instead to encapsulate computation that happens on the back end. Not on the back end. That happens in the background, okay? It's not connected to a UI, and so it also can last beyond the time span of when the user is actually looking at the activity. So if your application has, a couple of activities and a process, when you switch to another application and other activities come to the back, to the foreground, your activities will be paused and then stopped. But your processes will be able to continue running, okay? So the processes are used to do computation that you want to last longer than the user's attention span in front of your screen, okay? So in this sense, they are very useful and very, very important. Imagine that you want to do, a voice recorder that can record voice, but such that while you record voice for a 1-hour meeting, you can still use your phone in order to browse to web pages or, you know, check your calendar and do this kind of stuff, right? If you implement your voice recorder as an activity, then the voice recorder is going to be stopped when the user switches to calendar or to other activities in the foreground. But if you implement it in the background, if you implement it as a process, you can get to decide when to start it and when to stop it, and it can continue recording even when other stuff is in the foreground, okay? One good idea before doing a process is to check whether Android provides some class or some facility that essentially does the job for you. For example, let me describe a possible application. I want to do a shopping list reminder that when I get close to specific stores, it tells me what I need to buy there. Okay, so that, for example, if I always buy my groceries at 5 different stores, I can put each grocery in each list for the stores. Maybe some groceries I only need to buy them every couple of months, you know, because maybe those are these sort of difficult to get, but items that last a long time. And so you might imagine that I have to write a background process that constantly checks on my position, and when I get close enough to a store, you know, wakes me up. You can indeed write it that way. But for example, Android provides a geofencing service, so-called, in which you define a region on the map, a region, on a polygon of latitudes and longitudes, or points with a radius around them. And Android will wake you up automatically when you cross the geofence. So when you go from out to in or from in to out, okay? So there are some of these things for which you might think that you need to write a process, a background process, and my advice is to check, because often you don't need. For some of the basic things, Android is providing you services that do the same. Let me give you another obvious example. You need to upload big files or even images simply, right? You may think that you need to do that in the background, because if you want to be able to upload your images, there is I mean, you need to make sure that if the user switches momentarily to another application, your upload still continues. Okay, if you have only one image, that happens simply because Volley has background threads, and they are not necessarily stopped when you get out of the activity. So, in general, when you have an activity and on pause and on stop are executed, the only thread that is really stopped is the UI thread. If you have other threads, it's up to you whether to stop them or not. We discussed this already when we were talking about the web views, because you need to be mindful there that you need to stop the JavaScript threads of the web view, okay? So if you need to upload a single image, well, you can just wait until the Volley thread that you started by calling Volley in order to upload that particular image terminates, right? The amount of computation that you do while the activity should not be consuming CPU is very small, and so there is no big harm that you do by doing that, okay? But if you have a directory containing a lot of files, you really want to do, or if the file is very large and may take, some half hour to upload, you may want to really do it into a service that can have a longer time span in the background, okay? But it turns out that Android also for that provides you a background service. There is a background file uploader service. I haven't used it, but I read the documentation quickly some time ago. But I think if you pass it the right intent, telling it to please upload that file to that URL, it will do so and create some notification for you to know how the upload is progressing, okay? So there are, and I think it's true also for download. I mean, I forget the details because those are things I looked at a long time ago. But the message is simply, for some of these things you may do in the background, first check if Android provides a service. Because one of the reasons Android is providing these services is to try to conserve battery. Consider geofences, alarms, like the alarm you use to wake up in the morning, and a lot of these services. If every application built its own background service in order to check on these conditions continually, Android would be fairly busy all the time checking these things. If these things are sort of embedded in the operating system, then Android can, rarely wake up, check on all these various geofence and alarm conditions, and then go back to sleep in a much more power-efficient way. Okay? And in fact, in many cases, both for alarms and for geofences, you have options that you can tune on how often and with what degree of precision you should be checking the conditions. For example, when you set an alarm, you can say, do you want it to be truly precise, or do you want it to be, I forgot what the various levels of precision were, but essentially Android may check with a varying frequency, and if you are not particularly picky, may check only once a minute if you have a new alarm going on, right? That's why, if you set the alarm on two phones for the same hour, actually they don't exactly ring at the same second all the time, if you noticed, even though their time is synced to the time of the network, so the time is generally precise to the second, okay? You can do the experiment, and you notice this. So, long discussion just to say, it's not always the case that you need a background service, okay? And you should check whether there is something in Android already that gives you the same functionality. This is always true, before implementing anything, check whether you can reuse some component of Android. But in many cases, if you want to run in the background, then you need to implement a service. Other obvious cases are things like, music players. You can write code that, for example, records the movement of your phone. For example, that student a couple of years ago that implemented the app that was detecting potholes while you drive around, the potholes were recorded in a service. Because in this way, the user could use other apps in the foreground, like, maps or phone calls or whatever, but the phone would continue recording, okay? And so, by the way, services are really one of the things for which Apache Cordova falls short, right? Because everything that happens in Apache Cordova fundamentally happens in the in the browser or in the web view, you don't have this level of flexibility. So this is one of the fundamental reasons, one of the various fundamental reasons why you may really want to be implementing a native a native application. Unfortunately, services are a little bit complicated in the way they work. Let me just sort of give an introduction in this way. A service is a separate class, as you may know, may have guessed, right? There is an activity class and a service class that is subclass. But then there is the issue of how do you encapsulate the I mean, what is running inside a background service? Is it a process or is it simply a thread of the same process? So the example I'm going to do today will be the one in which the background service and the UI will belong to the same process. This is a bit confusing, okay? But let me recap terminology a bit. There are activities and services which are Android classes. And they have all their Android properties, meaning, you know, the activity has a life cycle, the service also has a life cycle, you created them in some way, you shut them off in some way, and yada, yada, yada. But the computation in each one happens, like in every operating system version, right, via processes and threads. I think you may know these from operating systems, or you may know these from, I don't know, computer science osmosis, in which you absorb ideas, even if you're not supposed to know them. But how many of you actually do know the difference between a process and a thread, or do not know? No need to be shy, but how many of you don't know the difference between a process and a thread? Okay, so just to remind, the thread is like, I mean, my vision of a thread is like the finger on the source code that says what line should be executed next, together with the values of the variables. Well, actually, not together with the value of the variables. That's the point, sorry. The thread is like the finger that points to the place you want to execute next. The thread is like, you know, multiple, if you have two threads, it's as if you have two people, each one of them has a finger pointed to the different places in the code, and these fingers are moving when the computation happens. So that's my way of visualizing the thread. So the thread is associated with a program counter, or, you know, a program location that your instruction register, now they're called, or whatever they are called, but essentially this points us to the places that will be, where execution, the next instruction to run, right? And a set of registers inside the CPU, okay? But different threads in the same process share the same data. So if you define variables in your code, those variables, the global variables of your code, are shared among the various threads, okay? So they use two threads in the same process, use different call stacks, okay? So the variables on the stack are different, okay? But the global variables and the global data structures are the same. So you can share memory directly between threads inside the same process, okay? Typically, when you fork a thread, you continue to share the same global variables, and you have two different stacks, okay? Now, processes are instead separate objects in the operating system. They really have, you know, each one of them has their own region of memory, and the regions of memory do not overlap. Okay, they can if you load the static code that can be shared, but that's a secondary point. Essentially, all the data memories do not overlap, okay? So the difference, as regarding to Android, the relevant differences are two. If you are in the same process, it's easy to talk because you share data. So if you make sure that you don't create conditions in which both threads modify the same data, if you are careful about that, and we will see later how to be careful, but you can communicate between threads by modifying their shared data. It's easier in general, right? You have shared memory between the two threads, and it's easier to use that. The other thing is that if you have an exception in a thread, for example, if a thread encounters a fatal error, then the whole process is killed. Okay? So it's not one thread at a time, but the fatal exceptions, if you have a null pointer exception, etc., it will be your whole process that will actually terminate. Okay? Processes are instead quite separate. You know, each one of them has their own region of memory. They will execute independently, and you cannot simply talk by modifying values to shared variables. You need to use operating system primitives in order to talk between different processes. In Linux and Unix, these primitives are generally, Unix ports and messages sent to the Unix ports. Okay, and in Android we have some additional mechanisms. Okay, so but there is this overlap between where is the computation encapsulated, and the answer is processes and within processes threads, and then there is where is the how is the class hierarchy organized, and the answer for us will be activities and services. Okay. When we create a service, you can explicitly say whether you want it to run in a separate process or not. There is a way to say it right at the beginning, and for this class at least, I will not choose that option, okay? But we may show it next week. So let me present these slides a moment. So if you want to declare a service in the manifest, so the way I would advise you to do it is to use Android Studio, and you can say, create a new service. Because this creates both, like for an activity, this creates both the class and does some of the right thing inside your manifest to declare that you can now have a new process, a new service. But what happens is something like this. There is a service which has a name, there is the class name is the Android name. Then there is a Android enabled, Android exported. Exported essentially means should other applications on Android be able to know about this service, right? Something like that. I mean, in your case, you don't have to worry so much. There is an icon which I'm not sure what it is used for, but it may be used for notifications or so there is a label, there is a set of permission, and then there is I don't know what the under process is, I forgot, but okay. Now, services come in two flavors. There are started services and bound services. The idea is this. A bound service is a service that is active only when somebody requests it. So once you create the service starts to live, and activities don't directly know how to talk to it. Okay, so there are ways that I will explain to talk to these services. One of the ways is to say, I want to bind to that service. Okay, so when the service receives a bind to this service, it becomes alive if it's a bound service. And when the last user stops binding to it, the service stops running. So that is what a bound service is. Essentially, it's like a service that is there to satisfy users, and it's alive from the first time somebody binds to it to the last time somebody is bound to it. Okay? For example, you can imagine that if you want to write a service that, processes acceleration data and tries to reconstruct a 3D position for your phone in certain ways, suppose that you write this as a service to developers of other applications, right? You can make your services accessible from other applications, as we will see. Okay, so suppose that you want to write a service that essentially cleans up the location data of the phone, uses accelerometer and yada yada in order to provide really high quality data. You would probably write that as a bound service, because there is no point running the service before anybody is interested in it. When somebody binds to it, the service should come alive. It should stay alive as long as there is somebody listening to it, and when nobody is bound to it anymore, it should go stop, right, and be reclaimed, essentially, okay? So that's a bound service. The other type of service is a started service. These are services that you start explicitly, and if you started them explicitly, then the services themselves have the control over their lifespan. For example, if you wanted to write a service that I don't know, a simple example, uploads a bunch of files, then it would be better to write that as a started service, right? Because you start it, but you don't know when it's appropriate for the service to end. It should go as long as all the files are uploaded. When all the files are uploaded, the service should be able to kill itself independently of whoever binds to it. In fact, binding to it would not be would not have to do with the task that the process has to do in this case. Okay, so these are the two flavors. So a service has these lifestyle methods, but I think I want to go to the sorry. I always. I have a lot of slides, but then I always want to go to some ones. So this is a lifetime of the two types of services, okay? So there is an unbounded service, I think it's called started service normally, and there is a bounded service. A bounded service will receive a call to bind service. So some activity will want to bind to it. Then the service will execute on create, on bind. Then here the services are the various applications are bound to it. There are various clients that can talk to the service. They unbind, and then the process is destroyed when everybody has unbounded. Okay. And in started services, instead, the first call the services gets is, instead of a call to bind service, a call to start service. You again do on create, but then you have on start command, gets executed. The service is running. Then you can yourself stop yourself. You can decide when to stop. And when you decide to stop, on destroy is executed and the service shuts down. Okay. So the part that is complicated is the following. The part that is complicated is, how do we create a process? How do we start the computation? Sorry, how do we create a service? How do we start computation inside a service? And how do we talk from the application to the service and back? These are the points that are the difficult ones. And I will do this for a started service. And it's a little bit complicated, and I hope I can explain it clearly. So if you are confused at any point, ask questions. And I have also the code that you can also look at in parallel, which is, right. Sorry, I put it on GitHub, but I don't have it. Let me refresh the code. Sorry, teaching Android service example. Okay, so this is the URL. It's called service example on Bitbucket. So, wait. So it's this one, and there are various branches, and I'm using the branch two-way communication. Okay? There are various ways of implementing the communication. So this time I want to present the two-way communication, and I think next time I want to present, or maybe later today, I want to present the communication done with event bus, which is a very nice library that simplifies much of the communication. Okay? So let me go into how to officially do the communication in Android. Wait, sorry. I'm having a bit of problems with, okay, Windows. So, let's see how to start a service. There will be three protagonists here. There is the activity, there is the service, and there is the service task. What is the difference? The activity and the service are two Java classes that implement, the activity that implements the UI and the service that implements all the various service methods. The service task is actually a runnable, and it is the thread that will be run inside the service. Because when you create a service, you do not automatically create the thread in order to run the service code. Okay? You may be surprised that this is done in this way, because when you create an activity, you don't need to worry about setting up the UI thread in a sense. But instead, for a service, you are responsible to set up the thread, the long-lived thread in which the computation happens inside the service. Okay? So we will have these three main objects as we go along. Okay? So let's look. There is a lot of information on this slide, but let's look slowly at how the thing is created. So the first thing you do is that from the activity you say start service and you give it an intent. We will see how to declare the intent, but essentially the intent contains the service class as the destination. You know that intent is what we use now from an activity to start another activity, right? When you want to change what is displayed on the screen. And so in the same way, or in a similar way, the way for you to create a service from an activity is to again create an intent that has as destination that service. Okay? So you create the intent and then you say start service with that intent. Okay? And that creates the service object. And the service object, this example is for created services. I do it for created services because I think these are way more useful to you. Bound services are useful for people who build infrastructure, like the Android people, because you build, services that have many different applications as possible users. But your typical problem when you build for Android will be to create a started service, some activity in the background, like a music player, a recorder, an uploader, a downloader, a this or that you decide when to start, and you want to go on even when the user is not having the app in the foreground. Okay, so that's why I describe started services. So from start service, the service is created. It will receive a call to onCreate. In onCreate, you can do whatever you want. You can initialize your variables, you can do a lot of stuff. But one of the main things we need to do immediately is that we need to create the thread in which the actual long-lived computation will take place. Okay? Because the thread that executes in onCreate is not long-lived. Okay? So, we need to do the following. The service task implements runnable, and so has a run method. So we need to create a new service task object. We create a new runnable from this definition. Okay? We create a new thread to run that particular runnable, and we start the thread. This is what will start the actual computation of this thing. Okay? Now, there is a funny thing that I always found very annoying, but is done with a purpose. That is, I've started a service. The normal, reasonable thing that you would expect is that when you start a service, you are given back some identifier that you can use to talk to the service. But this would be too simple, and so it doesn't happen. The reason is this, that in Android there was an effort to decouple services from the activities. There was a very bold idea that, I would be curious to know how far this has gone. I'm sure that this was very important in building the Android infrastructure, but I'm less sure it's useful for end users building their own apps. The idea was that you could add a service, and the service could work in very complicated ways, but was able to specify its own interface to you upon request, right? So when you start it, you don't get anything. And then you have to please ask to be able to be bound to it and communicate to it. And that you need to do with a separate intent. Okay? So you started the service, now it's alive and it's a started service. Then you bind to it. And then you have sent back a reference to it. Okay? Now, this works again in a very complicated way. There is some congenital inability of doing things in a simple way in Android, I often think, right? But so it works in this way, that when you ask a reference to bind to the service actually returns an instance of a binder class that can have all the methods you want in it. And to cut through this complexity of, asking to be bound to a service and getting a binder instead of getting the service that you really want to get, to cut through this chase, a common paradigm among developers is this, that when you bind to a service, you write a binder that has a method getService that returns the service to you. So what the code you write works in this way. You bind it to a service. When you get the answer, you get the binder, you call getService on the binder, and then finally, after all of that, you get a reference to the service you have just created. It's incredibly obnoxious, okay? But it is so. And I can show you this in code. Maybe, in fact, it would be a good idea to show you this piece in code, how to start the intent and how to bind to it. First, I'll show you from the activity side, okay? From the activity side, this is the activity. I set a variable service bound to false. Oops, sorry. Am I in the right branch? This is actually with event bus. 1 second. I think I need to change the local branch in which I am. A moment. I think I need to go to master. A moment. Git checkout master. Okay. Wait a moment. Okay. Okay. It's building, but it will stop building in a while. So I have to redo this business of updating, from the older Android Studio I was using. It will just take a second, but it will do it. So, okay. So I say that service bound is equal to false, okay? Then, here is this portion of the slides. Wait, 1 second. So, you see that on the slides I started the service, this creates the thread, etc., etc., but then I need to bind to the service and I need to get the reference to the service, okay? So this code happens here, okay? So on resume, I create an intent to my service class, I start the service, and then I bind to the service. When I bind to the service, I run this code, okay, in which I create another intent to the service, and I call a method bind service. I could have joined this code, I guess. I don't need to have it separate. So essentially, I create two intents. One I feed it to start service, the other one I feed it to bind service. Okay? When to bind service, I have a callback that is called service connection. Okay? This callback has two methods, onServiceConnected and onServiceDisconnected, that are used to me to communicate when the service is connected and when it's not connected. Okay? And so when the service is connected, you notice I don't get the service that what a reasonable person would want, because Android would have wanted essentially to create a firewall between the service and the users of the service, so that they would be able to change their class implementation at pleasure, and all people would be given when you bind to a service is a binder that can have other methods defined. You know, it's like a level, you know that I joke that in computer science you solve all problems by introducing one more level of indirection, right? And this is exactly one such example. They want to be able to change the implementation of these services at will, so they don't want to give to applications back their own service. They want to give it this binder that is like this man in between you can call methods to the binder, and then the binder will take care of calling the service in the right way. It's like an interface adapter. I don't know how to call it. That's the idea. But since it blows our mind, the idea of having to use such complexity in our own projects, to define these intermediators, even when we between ourselves and other piece of ourselves, we don't want to do that, and we simplify. So we define this binder to be a very simple object that has basically only one method that we defined. The method is called getService. So once we get the binder, we call getService of the binder, and we finally get a reference to our service. Okay? We say that the service is bound, and we do whatever we want. In this case, I say add result callback, and I will show you later what that does. Okay? So all this boilerplate code up to here is to start the process and actually get a reference to it. It's somewhat crazy, but it is this way. Okay? Any questions up to now? So we can go look at the other classes. We can look at the maybe later. Sorry, one complication at a time. Okay? So good up to now. Let me update the code also of the master branch. Git commit. So you have the code. Okay. Now, so we have done essentially this piece here. Once you get a reference to the service, you can call methods to it. And so, the typical way to talk to the service, if you need to or let's say, one of the ways to talk to the service is the following. Now that you get a reference to it, you can call in the activity myService foo, where foo is a method of your service. In the service, you have the implementation of the method foo, right? And then, if you like, you can call this task foo, which is a method of your actual service task, which is what implements runnable. Okay? So you can call down this chain and actually touch the variables in the thread that is running the service. One of the problems if you do this is that these calls, so this is something that always confuses me, but it's always, it's kind of necessary to be so, but I find it always confusing. Think at it this way: when you call my service foo, you are supposedly, or for instance, you may be in the UI thread, right? And the point is this: thread boundaries do not correspond to code boundaries. So even if you call code that belongs to a service or to service task, if you call it from the UI thread, you will be running that code in the UI thread. I find it, mentally very disconcerting. Now I'm kind of semi-used to it. But, initially I found it very mentally disconcerting, the fact that the boundaries of threads and processes do not match with the logical boundaries of classes in Java, right? So when you call from my service foo and you call the method foo of the service, you're still running in the UI thread. Fine. And moreover, when you call my task foo inside the task, this code is still running in the UI thread. So this code is not running in the same thread as the service thread that is long running and you set up. Okay? So if in this call you modify variables that are read by the service thread, you have to be careful about consistency of your variables. You have to decide, can bad things happen? And if so, you need to protect via mutual exclusion the access to the shared variables. Do you know what mutual exclusion is, or how mutexes work in operating systems? Yes, no. Kind of. Have you ever used them? Okay, so this will be the first time we need them. Essentially, let's maybe get to that a moment later, though. Remind me that I have to cover some of that, okay? Now, let me just give you an example of all of this code. And I haven't gone to the second slide yet, which is how to talk about the service gives back results to the main activity, okay? Let's focus on this direction of communication. Let's see now all these various pieces. So we have seen already in the main activity, we have seen, to make a quick summary, okay, that we call start service, then we call bind service. This has a callback. On the callback, we get a binder. On the binder, we call the get service method, and we finally get a reference to the service. Let us see what happens on the service side, how the rest is implemented on the service side, okay? So let me go to my service. My service is a service. So if you look at it, it's a class that extends the service, okay? And in it, I define two important things. I define a thread that I will use for doing the long-running computation, as I mentioned to you, and the task that will be the runnable executing this long-running computation. Those are the fundamental two pieces that you create in there, okay? Then I also define a binder, okay? My binder class is this one. It will be returned when I try to bind to the service. You see, because I want to take a shortcut, I did not invent this, somebody before me invented this way of shortcutting some of the complexity of creating services. But the idea is that I create a binder that has a method getService, and all it does is it returns my service.this, so it returns the service itself. Okay? Do you know why I need to say my service.this instead of simply this? If I say simply this, I would be returning an instance of an instance of my binder, right? I need an instance of the service where this is defined. Okay? So this creates a binder that has a method getService that returns the service itself. Okay, my constructor doesn't do very much. And on create, so I display a notification. You know, it's good form if you are running something in the background for a long time. It may be good form to display a notification in the status bar so that you know that something is going on. So in this case, I build a notification and I display it. And then the important part, I create the thread. I say running the camera service. This is because I adapted this code from when I was trying to use a camera. I say simply running the service. So what do? I create a task, okay, which is the thing that can run. I create a thread to run that task, and I start the thread, okay? So this actually creates the thread. There is an important thing. When you created the service thread, you have to create it in onCreate. You should not create it in onBind, because onBind can be called multiple times, and you don't want to end up, unless you really need multiple threads, you don't want to end up with an uncontrollable number of threads, okay? So when you created the service, you created this long-running thread. So now, unfortunately, we are left, instead of with one object only, we have two things, you know? We have the service instance, and then we have this task that is running in this new thread that now has been started. Okay? Which, I mean, is complicated, but that's what we have left with. Okay? On the onBind method will just return this myBinder that I defined above, right, as this thing that will return the service itself. Perhaps, you know, this would be clearer if I moved it up, even though obviously it's the same. But let me put it closer to that other code, okay? Let me reorder this code a tiny bit, actually, since we are at it. So this is binder class, and I can put this down here, okay? So this is the binder class. Then I define an instance of it, and when somebody calls onBind, I return that. Okay? So, in onStart command, if you look at the life cycle, but if you look at the life cycle, you see that there is a first onCreate and then onStart command. So, onStart command, the thread will already exist, generally. So what I write is this code. We start the task thread if needed. I don't know why I wrote this, but I wrote it out of security, but I think this is generally not needed. You should start the thread in onCreate and not in onStart command. Okay? So, but if we don't have any thread, we start it. And we have to return start sticky. If you look at the documentation for the onStart command, there are various codes that we can return. Start sticky means not only we start, but we will continue running until we decide that we want to die. Okay? There are other ways to start in which you say that you start, but you don't want to continue running, etc. You can look at the documentation. Okay? In onDestroy, what you do is that you say my task, which is your thing that is actually running, is the runnable, and you say stop processing. So you tell to your task to please stop processing and stop running, okay? And that's it. This we will do later. And then there is code for a notification. I mean, it's a little bit, I don't know. Any questions up to now? Everybody is utterly confused, eh? A little bit so. I don't know how to make it come more alive. So maybe we can ping-pong back and forth between the service and the activity when they start all these. It's like starting a car engine, you know. There is lots of stuff that happens all at the same time. The ignition, engine, the injection, the whatever else, all at the same time. So, again, let's look at it looking at the various pieces, the starting of these. The start happens, sorry, I'm confused myself in my own code. Here. So this first intent says, I wanted to start the service. And I haven't bound it yet, okay? So that's how, from the activity, you start the service. Let's look at what happens on the other side, on the service side, okay? On the service side, the first thing that happens is a call to onCreate. Okay, in onCreate you say, oh, I've been created, that's absolutely great. I put up a notification, I create a runnable and a thread, and I start the thread. So I do this in onCreate to guarantee that I have only one of these long-running threads running. Okay, in onStart, I just do that. It's like you have switched on the engine of the car, but you haven't started anything else yet. You're not driving the car yet, in a sense. Okay? Now, from the main activity, I wanted to bind to the service. And so I send another intent that says, please, I want to bind to you. And in the service connection, I will get back the binder, and to which I will call getService to actually get the service. Okay? And here, what I do is this. OnStart command is called automatically and is not so important in this case, but the important one is onBind. OnBind works in this way. It returns my binder. My binder is this instance of my myBinder class, which essentially has a single method getService, which returns my own service. Welcome to Java. Okay? I was laughing yesterday as an aside. I'm using, playing with the TensorFlow and Keras in order to do some machine learning. And so, you know, one of the things you do after you learn a model in machine learning is that you have to save it. And so in Keras that was born, by Python programmers, there is a method, you have a model and you say model.save, because, you want to save it, so you say save, that's kind of natural to me. But not in TensorFlow. TensorFlow was born, I think, by some Java programmers. So you cannot save something directly. That would be too brutal, It's like, I don't know, drinking out of the pot directly, One of these things you just don't do. You have to create a saver. And only once you have a saver, you can actually call the save method on the saver in order to please tell it to save politely enough so that the thing is actually saved. And it's not saved in one. It's like, when you dine with a silver cutlery, and you're not supposed to touch or do certain things, this is Java. You don't just grab your knife. You grab, the special napkin with which you are supposed to clean the knife handle before you actually take it in your hand. Or something like that, There is always one more level of indirection to life. Yeah. So this is one direction of the setup of the communication, and this is unfortunately unavoidable. Even when I will later tell you how to use event bus in order to communicate more easily inside an Android application, this boilerplate you still have to go through it. Okay, and so it's boring, but at least I've shown it to you, because when I tried to do it for the first time several years ago, there was no such boilerplate that you could actually download and get it to work, because it was documented in bits and snippets in a gazillion different places, and I think I went nuts for a couple of days to put it all together reasonably. Okay, you can imagine me going nuts writing this, right? Especially given my mood of somebody who is not very patient necessarily. Okay, so great. Now we are connected to our service. Questions up to this point? I want to show you how to communicate information to the service itself from the activity. But questions up to this point? Is it somewhat clear? Or at least is it as clear as it can be, and then you will have to look at the code by yourselves, I guess. Okay? Great. Now, how do I pass a little bit of information to the process? So the way is this. If I call foo from my service, I can have a method foo in the service that calls a task foo in the task that will do something in the actual class in which I do this. So why do I need to have these two steps? Well, this because, I need to call foo on the service, and so it will get run in the service. Why can't just I get the job done here, please, and not there, right? So why do I need this other level of indirection? Well, the reason is that my service task is a class, and so it will have all its local variables. And the local variables of the service task, if they are private, they are not accessible from the service itself. So the thing that you usually do is from the service you call this method of the service task where you are in the right object finally to actually do the job you want to do. Okay? So let's see how this chain works if I have one such chain in my code. Sorry, I'm looking at the wrong place. I need to look at the activity. Sorry. One second. Oh, interesting. The only method I seem to be calling is add results callback. Wait, why? Yeah. I'm sorry, I needed to implement a simpler method. Maybe I should implement it. Just for the... Yeah, there is nothing that will call it, but let me invent this method just for you to see how it can possibly work, okay? So here is an example of a method that calls something in the service, okay? And so I let's pretend that somebody pressed a button. Void on button press view v. Okay, so if we wanted, we could run this code if somebody presses a button. Okay, and then we can say my service, which is my service, like do something, okay, in which I pass, for example, an integer and a string. Okay, I mean it's just completely an example. Okay, but suppose I wanted my service to do something on an integer and a string. Okay, maybe I should git checkout branch like do something example. Okay, so let me implement this method do something in the service. Okay, so here we have a lot of methods, and I can I don't know where to put it. Okay, fine. Okay, so now we have a public void do something, and this takes an integer I and a string s. What is it? String s. I write too much Python. Okay. And this is all very, very well and good, right? And you can call it, but I'm not in the service thread, right? That's my problem. So what should I do? I should take my service thread and call the do something method on the service thread. So we don't actually do anything. We need to ask the service thread to do it for us, okay? And so what I do is this. Which one is my runnable object, right? I created it, so I should know which one it is. But it is this. It's called my task, okay? That's the thing that is running there. That's the object that's running. That's the runnable object, of which we call the run method by starting the thread, okay? So that's the object that's running. Now, I take this my task, and I tell it to do something on I and S, okay? Now, this is, I get an error simply because I haven't defined this method do something. Let me go define it. So now, I get my service task. This is the actual runnable. So this is what implements runnable. And in fact, you see that it has a method run. And we go later into the details of this method run, okay? I want to explain to you later what we decide to do. But let's not worry about what it does when it runs for the moment. Let me just say that this thing here are, fake variables to pretend we do something, okay? And so I can define private string s is equal to the empty string, and private int I is equal to 0, whatever, okay? So these are my two variables. And now I need to say public void do something, okay, of int I and string, int I and string s, okay, something like this. So those are the formal parameters. Maybe it is not nice in Java to name things this way. So I don't know. Every language has its own conventions, whatever. Okay, so now I have to assign these variables to the object, okay? And here lies the problem. So the process, if s were useful to the background process, the process might be using this string s, right? So there is a thread that is using the values of I and s, plausibly. And now I'm going under the feet of the thread to change some of those values. And all hell might break loose, no? Because an integer is a single location in memory, and perhaps you can get by, because you change it quickly, sort of, no? You change it in a single write. But a string is long. You cannot generally write a string in a single access to memory. So while you write a new string, the Java might be reading the old version of it. This could be even worse instead of a string if we were changing a bigger object. For example, I might have passed in this function, a hash table or a hash map in Java, or one of these array lists, or one of these complicated objects. So what happens? Can I, in general, just swap data from under the feet of a running thread? So in general, you can't, okay? And I cannot get into very complicated issues of Java concurrency here. But I can tell you that there is a distinction in Java between some elementary types that are always atomic in the way you mutate them, which include Boolean and integer, and I believe also float. And then there are I don't know how to say, but essentially non-atomic update types, which include strings, but includes also in general all the objects, for which you really need to create some protection if you want to change them. So let me do these updates in a way that avoids the risk of inconsistencies, okay? So, an integer can be always changed atomically. Okay, so I can say I is equal to II, and that will be okay. For a string, we need to synchronize. Okay, and so I have to define a mutual exclusion semaphore. Oh boy. I didn't prepare this, so I know how to do it, but if the TA is searching in case I make a gaffe. Is it not called mutex? How is it called, the mutex? Synchronize? Oh, no, I'm stupid. In Java, I can just use anything. So, I think I can just do these. I think that this is fine. Problem solvers. Okay. Okay, I think that this works actually. Can the Java Grooves comment? Okay, so what I do is this. I want to create a region of mutual exclusion. So I want to create a region of code in which I can be sure that there is only one thread that is executing it at any given time. Okay? Essentially, there are two threads that can possibly touch this value of S. There is the thread that is running in the process, in the service itself, not that we created in the service, okay? And then there is the UI thread from which this call to do something comes from, okay? Visually, there is, below this service thread, and on top there is the UI thread. The UI thread tells do something to the service. This tells do something to this object. But this variable S then can be read or written by two different kinds of things. By these calls that go through from the UI thread and from instead the service thread itself, okay? So what I want is that some regions of code can be modified by only one of these two threads at the same time. Have you seen these already, or who has not seen these already? Don't be shy. I mean, it's not a prerequisite operating systems, but how many of you have not seen these already? So most of you now have seen it. No, not all. Okay, some percentage. I don't know. In Java, to create a region that is in mutual exclusion, you do this. You know that objects are like parsley in Java. You use them all over the place, right? So what you do is that you create an object M that absolutely has no purpose to us, except it's an object. And then we say something like this. We synchronize on M to do this assignment. That is, in order before you can do that assignment, you have to acquire the exclusive use of that object M. The object per se has absolutely no use to us whatsoever. It's just there to record the fact that to act as a guardian to this section of code. That's the right way to think at it. Okay? Inside a synchronized M, there can be only one thread. If I had synchronized M and synchronized Q, then two different threads could be one in M and one in Q. Okay? It's as if M is a single key to a room. No, synchronized M is like I have the key to M, to this section of code. I can go in, and when I'm done, I give the key to the next person who is waiting in line if there is one, or otherwise I will be out of there. No? It's like the service stations on the highway with the key for the toilet. The key to the toilet is the object M. Okay? And so if I want to use S inside the thread, if I want to read it, I would have to acquire the key to it. There is another point that is important to notice. Even for variables that are atomic in their update, such as I, once you have multiple threads that can write to it, the value of I can change from under your feet. And you have to be careful in writing your code. It's not a given that every time you write I will have the same value. Okay? For example, suppose that I'm crazy enough, maybe not crazy enough, but in some place where I run, where do I do? I don't know where to write this sample code, okay? But for example, I can write it here just for why not? But I can say if I is greater than 0, do something, and if I is smaller than 0, like do I ever get here? And so do you ever get there? And the answer is, yes, with a very, very low probability, actually, but you do have non-zero probability of getting there. Because, I might have changed from when you run one statement to when you run the next. In this case, it's incredibly low probability because, these two tests for the value of I will be executed in very short succession, okay? But suppose that instead of writing the code in this way, you say, while I is greater than 0, and you say, do a bunch of long-lasting computation, okay? Then in this case, the probability that I actually changes would be higher, okay? And so you have to keep in mind which variables you are sharing. And if you want to have a consistent copy of a variable in multiple places in your code, you may want to copy that shared variable inside some variable that is not accessed by multiple threads, and then use the copy instead, for instance. I mean, you have to take care of thinking through how your shared variables are used. Okay? Now, let me... since we are talking about it, let me talk about, how you terminate a thread. So the obvious way would be to take the thread and kill it. Okay, and in some cases in Java you might even be tempted to do that, but never in Android. So in Android you should never ever kill a thread, okay? Because the Android keeps associated stuff with the threads, and if you kill it, you prevent a proper cleanup. So the rule is that you should never kill a thread in your code. I mean, if it dies because a segment, some kind of memory fault is, or null pointer or whatever is fine. But you yourself, you should never kill a thread. What you should do is that inside each thread, you should periodically check whether you are still running. Okay? So let's look at as an example of thing that can actually mutate at how to tell that a thread should stop. The typical implementation of the run method is this. You set running is equal to true, and then you check whether you are still running. Okay, you check periodically whether you are still running. So you see, this is a clear example in which if you just read this code in isolation, you say, obviously, I mean, what can change the value of the running variable? Well, there is something that can change it. That is, when in the service, why do I still get an error? Sorry, it's just that the analysis had not terminated. There is no error. When in the service you get a request to stop on destroy, wait, sorry. When on the service you get a request to stop processing, when you are destroyed, right, because somebody stops you, what you do is that you call the stop processing method of the task. The stop processing method sets running is equal to false. You see, unlike below, for M, for S, but like what we do for I, we don't need to bother with mutual exclusion. Maybe I can add a comment, okay? No need to bother with a synchronized statement. Booleans are atomically updated, okay? So I don't need to bother with a synchronized statement. I set running is equal to false. Here, in the main loop of the thread, I'm periodically checking whether I should still be running. At some point, that flag in the while loop will be false, and I will exit from the thread. How do you exit from the thread? You don't do anything special. You simply finish executing your runnable method. When the call to run terminates, your thread will also gracefully terminate. Okay, and that's how you ensure that that you stop running, essentially. Okay. So now I've covered essentially how to start a service, how to bind to it and give back the reference, and how from the UI thread to talk to the service, taking care of mutual exclusion when you need it. Okay? The one thing I need to tell you, and I'm sort of wondering whether to tell you, is how to give results back. I'm somewhat thinking that so there are two ways. There is the official Android way, and then there is a much nicer and easier way that somebody built upon it that is called Event Bus. I'm sort of wondering what to do. I mean, I can explain it, but the point is your brain full already, like the Calvin and Hobbes joke. Now, would you like me to get into that? Or shall I get into how to report results back next time? Vote for now. One, okay. A few votes for now. Let me explain how to. Let me explain some of it now, and then if you have questions, we can continue next time. Okay. Reporting results back. It's. We want to do it in a slightly more sophisticated way, meaning that. Typically, from a service, when you have a result that you want to report back, you don't just want to change a variable in the activity. Because if you change a variable in the activity, nobody is going to see your change. I mean, it will be there for when the code will next run. But remember that the UI thread is not generally running, right? The UI thread is running in response to some event, which can be a button touch or something that comes, through the some incoming intent or some other stuff. Okay, so suppose that the service is as in this case. Let me show you what this service is actually doing. What this service is actually doing, in my very silly example, it's sleeping for 1 second, and then it's getting a random number and is sending it back in some way. Okay. And what I would like to do, obviously, when I generate a random number and send it back, I would like to display it on the screen of the activity. Okay? So we need to do something slightly more complex. I cannot simply, call back the activity. So first of all, notice I don't have a reference to the activity. So I don't actually know how to call back the activity. We went through all these jumps and hoops so that the activity can have a reference to the service. But the service does not know the activity that bound to it. It's never told even. Okay? So that's the first problem. And the second problem is that we don't only want to change an integer in the activity. We also need to poke it to life so that the integer will actually get displayed on the screen. So there are these two things that need to be done. And I do these two things following, again, a very common design paradigm, essentially publisher-subscribe. It will be done in this way. The activity is the one that knows about the service. So the activity will start by saying, oh, please, my dear service, here is a callback for you to call me whenever you have results. Okay? So the activity will subscribe to the service updates. When the service has an update, the service will call all these callbacks. And these callbacks, yes, it's complicated, but these callbacks will generate a message that will be able to wake up the UI thread of the activity itself. So that's how it works. Let me go slowly through the code. So, it's done in 2 steps. First, the activity registers with the service. So, it calls a method to the service that is called add the results callback, in which you pass the activity itself. Okay? This gets passed all the way to the service task, which adds a results callback to a list of things that it has to call whenever it has results. Okay? This is the first step. Let's look at it in the code a moment. So this add results callback works in this way. From the main activity, sorry, I'm trying to look at okay, once the service is bound, what you do is this. Say, my service add results callback to main activity this. So I am essentially saying, please service, call me back when you have results. Let's see what the service does. The service calls add the results callback on the task. By now you have understood that there are these like 3 different actors. You know, there is the activity, the service, and the service thread. And the service runnable, okay, the service task, right? So from the service, you call add results callback to the service task. You are simply passing it along, I guess. And from the service task, what you do is this. You have this list of results callback, and you are adding 1 element to it. Okay? So you are building the list of everybody you need to call back. Now, the interesting part is this, you know, you may tell me, hey, look, these results callback in which you add an element to the list, I mean, don't you need to be careful with it and maybe protect it with a mutex or something like that? Because, you know, in principle at least, this is not your thread. I mean, in fact, this is not your thread, right? There is somebody else calling you from the UI thread, in fact, that is asking you to modify one of your data structures, and this list is certainly not an elementary data structure, so why don't I have a mutex there? Okay? The answer is that in Java, there are some data structures that are resistant to concurrent modification. And here, if you look at how I define my result callback, I define it as an example of a synchronized set. Okay? So I'm essentially returning a synchronized version of a set. This means that this particular data structure is resistant to having multiple people call it and read it at the same time. How is this done? It's not really black magic. It's simply that the synchronization, instead of me having to manually add it outside of the data structure, has been added inside the declaration of the methods of the data structure itself. Okay? Essentially, that wrapper that says collections synchronized set, in which you pass it to the object, that wrapper will essentially add the required synchronization to the methods of the data structure. Okay? So it's called the synchronized data structure in Java. And for those of you who will, become wizards in Java, these are important things. These are data structures that you can use, share among multiple threads without risks of, trouble, and without having to remember each time to use a synchronization primitive. So in this way, the activity has registered itself with the service in order to receive updates. So that's one half of the communication. It's as if saying, please let me know when you have a new random number. Now we have to see what happens when the new random number is generated. Okay, so what happens? Let's follow the code directly. What happens is this, okay? I get a new random number, and I say notify results callback of this random number. Notify results callback is my own function, okay? I just put it separately because of, better coding style. Let me say what I want to do in general. What I want to do is go through the list of people that want to listen to these random numbers and notify them one by one and send them somehow this random number, okay? And the way I send it somehow is the following. Oh boy, this is a really complicated implementation that I chose. But essentially, I have these three results that is a concurrent listed queue, concurrent linked queue. So what is the problem? The problem is a little bit this. Maybe we should cover it next time because the time is running out. So maybe I should just give you the idea of what I'm doing now and you can look at the code and next time we can walk through the details. But the idea is that there is a small problem here. I'm generating random numbers and I'm notifying the thread. But I don't want to be hang on waiting for the UI threads or whoever consumes these random numbers to delay me. Okay, so I need to put them into some sort of intermediary buffer where I can essentially put the number there and be done and go back immediately to producing the next number. Okay, and the number, once it's in that queue, should be passed to the various receivers of that number. So what I do is that I have a bit of code that I would encourage you to look at for next time that does the following. It tries to find a free service result, and if so, it puts the result into the service result and then loops for everybody who wants to be called, and it calls their onResultReady method. This onResultReady method will help. Sorry, this onResultReady method will do something complicated, unfortunately, still. I mean, it's really a very super complicated thing. I don't know, maybe I should... I don't know what to do, I mean, to simplify it. I mean, the reality is complicated in this case. It cannot directly pass this method, this value to the UI thread, because the UI thread is another thread, and it needs to create something that can possibly wake it up. That something that can possibly wake it up is a message. So I have to obtain a message, and I have to put the result inside the message. The message will be handled by a message handler by the UI thread that finally will display it. I know, it's absolutely crazy, right? Look at the code for next time, and next time we look at it together. But essentially, there are these steps. You register with the service, and when the service wants to send a message back, it has to find a place in this buffer of results that are sent back. Notify all the listeners that there is a new result back. Every listener will execute this onResultReady. It will take the service result, which is this, this element of the result buffer, okay? And it will obtain a message, and it sends the message to the target. The target is the UI thread itself. I will explain you next time in detail, okay? Then there will be a method in the UI thread. I just give you the course structure so that you can look at it. But then the UI thread will execute this method that is... on message. Come on, where it is? Sorry, I get lost in my code. Here, okay. This is these implements the callback, and this is what has the handle message method. And this thing here finally is called in an event-driven fashion in the UI thread, and can actually display something on the screen, and so I can do the text view TV in which I get the text view to display the number. So there is this absolutely crazy, complicated communication way back. And what I have to tell you for next time is essentially this. Look at this code and look at these slides that tell you how to register and how the communication back works. Okay, and we start from there again.